Okay, here is the question. I think it's 1C from the 2012 paper, I guess it is, the St. Cuthbert's paper. Anyway, here's the question. I think we're okay with up to this point and how we're doing it and so on. And so let's go through this. Now, we know that we have to look at the probability that 2010 is greater than 2011. Okay, so we know that. And basically then that means that we're looking for the probability that the difference between those two has got to be greater than 0. Okay, so we have to establish that's what we're doing and that's where we're going. Now, once we've got that, then obviously we're going to do the easy thing, which is find the difference between the means, difference, and that's just a matter of taking your 3, 2, 5, 5, 0, 0, and minusing the 3, 8, 5, 2, 0, 0, and we get a negative 5, 9, 7, 0, 0. So that's the difference. That's the mean, the difference of the mean, okay, between those. And we've got that, and so we can record that somewhere and have that to look at. Now, the problem comes when dealing with the standard deviation, because you can't use the standard deviation of individual variables. You've got to find the variance of each one of those and then revert back to standard deviation. So this is how it works. So basically, I've got to find variance, which is standard deviation squared, for 2010, which is just simply taking 73300 and squaring it. And then I've got to do the same thing with 2011. I've got to square it, 58800 squared. And so I'm going to square those. Now, once you've squared them, to go back and find standard deviation of the two, you've got to square root. So basically, take the standard deviation of any combination of variables, whether it's adding or subtracting. You always add the variances. You never subtract them, no matter whether you're dealing with a difference or not. Okay, so this is what you're doing. You're taking your 73300 squared, plus it's always adding with variances, and the 58800 squared. And you're finding that. And when you do that, you're going to get a standard deviation for the difference of 93969.8, which they've just rounded off to 93970. So there's the standard deviation. Now that, along with the difference of the means, or the means is what we put into the calculator. And the trick comes with using the calculator. Okay, so now we've worked out these parameters that we need. And we're going to need to pull up the calculator and put these parameters in. Now, the biggest problem here is this is our mean for the difference, and this is our standard deviation for the difference, and this. Now, when you go into normal and you plunk in things, you have to have a lower limit, an upper limit, the mean, and the standard deviation. Now, the lower limit's not a problem with this because greater than 0, so you start at 0 and you go up. Now these are really large numbers. You've got a standard deviation of 73,000 or whatever, and basically you've kind of got to double that to make sure that you get above these numbers. So I'm going to put some crazy thing in, like 500,000. And then the mean, which is negative 59700, and the standard deviation, which is 93970. That's what's going to go into the calculator, and that's what you put in. So let's do it. Let's go to distribution, down to normal, CD, and then let's put in 0, and then some ridiculously large number. The standard deviation, or the mean, sorry, which is negative 59700, comma, and then the standard deviation, which is 93970, and put a bracket around that. And there we go. And that's the answer. That's the answer of the question. What's the probability that the houses sold in 2010 are higher than the prices in 2011? And that's the probability, and that's how you enter it into your calculator.